Now we are going to discuss question number 5.23, and in this question it is given to you a sample of paramagnetic salt contains 2 into 10 to the power 24 atomic dipoles, each of dipole moment 1.5 into 10 to the power minus 23 joule per Tesla. Clear? So now we can say what is total number, we can say what is total atomic dipole what is total dipole moment. Can we calculate? Yes. So we can see, if I am right here total dipole moment, this is given by 1.5 into 10 to the power minus 23. This is what? This is dipole moment for each atomic dipole. Clear? And this paramagnetic salt contains 2 into 10 to the power 24 atomic dipoles. So it is multiplied with 2 into 10 to the power 24. So we can say this is 3 into, I can say 3 multiplied 10. So directly you can say this is 30 joule per Tesla. But in this question it is given here that the degree of magnetic saturation achieved is only 15%. So what is actual magnetic moment? Actual magnetic moment is 15%. So I can say this is 15 by 100 and multiplied with 30. This one and this one cancelled out. So 45 by 10. So I can say this is 4.5 joule per Tesla. Clear? 4.5 joule per Tesla. Clear? This is value of M1 we are having. It is also given here, this sample is placed under a homogeneous magnetic field of 0.64 Tesla. Clear? It means value of B1, this is also given to you 0.64 Tesla, and it is cooled to a temperature of 4.2 Kelvin. So value of T1 is also given 4.2 Kelvin. Fine. Now what is our objective? Our objective here is to calculate total dipole moment of a sample for a magnetic field of 0.98 Tesla. So value of B2 we have 0.98 Tesla and at a temperature of 2.8 Kelvin. So I can say T2 this is equal to 2.8 Kelvin. Now in this question it is given, we have to assume Curie law. So according to Curie law, I can say M, this is given by something constant and multiply with B by T. Clear? So we can write like this, M2 by M1, this should be equal to B2 by B1 and multiplied with T1 by T2. Clear? So M2. Now we can say M2 divided by M1. M1 is given to you what? That is 4.5. Clear? Value of B2. B2 we have 0.98 divided by value of B1. B1 we have 0.64 multiply T1 by T2. T1 is given 4.2, clear, and T2 this is 2.8. Now we have to just simplify it. Clear? From here you can say this one and this one cancel out. This one we have 4 and we can say that is 7. So we can say this is 6. Yes or no? Now from here we can say yes. From here we can say this point and point, this decimal is cancelled out. 0, we can say this is 2 and or you can say this is 2 and we have this is 49. Clear? Now we can say this one we are having that is 3. Clear? So now we can say this is equal to what? M2 divided by 4.5, this is equal to 49 multiply 3 divide by I can say that is 64. Clear? So can we calculate here value of M2? Yes. So value of M2 that is given by value of M2 yes. So value of M2 that is given by M2, this is equal to 4.5 multiply 49 multiply 3 divided by 64. Clear? So now just multiply, actually we have no option, so directly we can say this is 45 or we can say 64. So just if you multiply it with 3, I can say this is 15, we have 1, 13.5 multiply 49 divided by 64. Clear? You can take here some approximation. Let's suppose you are assuming this has to be 48. Clear? So if you cancel out with 8, I can say this is 6, this one is 8. Clear? You can say this is 3 and we can say that is 4. Yes or no? So this is 4. So from here you can say we have 15, we have 1, this is 0, we have 1, 40.5 divided by 4. So approximately we are getting this is 0, 10.125, and I can say this is joule per Tesla. Clear? So this is approximate. We can say you can calculate like this. So this is value of total dipole moment for the sample of magnetic field at a temperature 2.8 Kelvin and having magnetic field 0.98 Tesla. Clear? So this is all about this question.